Hey guys, so today we're going to cover how to create your own YOLO data set. And essentially, the Ultralytics has written a great set of tools that will help you train visual categorization and recognition models. This is just my take on a visual trainer, just to make it a little bit easier to allow you to start from scratch, annotate a set, and even do some auto annotation to help speed that process up quite a bit. So to sort of show how this works quickly here, we're going to actually write a system that detects whether something contains a QR code or a data matrix code. Those are types of barcodes. And not only will it detect those, it'll give out a bounding box as to the location on the image that they exist in. So currently when the Majorsoft YOLO dataset viewer starts, you'll start off in model management. There's really no models in this. These are all the Ultralytics models that will be downloaded automatically when you use them. And so what we're going to do right now is we need to create a data set. In this case, you've already got your images. If we take a look in the folder I include with this project, there's a data set here that's from someone else that's attributed into the original data source and where it could be found. This is version 1 of the data set, which I liked a bit better for what we're doing. And in this case, it's all of the images plus their annotations. We're going to be starting from scratch here without the annotations, but this is where we will start. So we need first to get the data set. And in this case, we're doing QR codes and data matrices. So let's create our first data set. And where I'm going to save it is in the root of the project root for now, just so the default is good, data.yaml, save. And the root folder for the dataset root, which is essentially the working folder, which we don't have here yet, so we're going to create a new folder in this root called working. And select that. The other ones are good. And we're going to add 2 classes. The first one will be QR, and the second one will be data matrix. And you can add as many classes as you need to recognize different things. Hit save, and we are good to go with this. Next, because we are doing a tutorial, let me just... we're going to copy these images into another folder, and just the images. So I'm going to make a folder called Annotated Test Set. And I'm going to grab just the images sorted by type. There's about 900 images. Skip all the text files. Let me see where these are. Almost there. Okay. So just select all of the JPEG files, copy them, go back to your training tools, and put them in the annotated test set. And this just lets us isolate them in case you want to use the original training data for something else later on, or your own explorations. So now we're working on a set of images that have no annotations. So going back into the YOLO dataset viewer tool, we're actually going to split the data, but first we're going to annotate just a number of images so that it actually has something to split into. We're going to use a folder browser for this. So go into the folder browser, click on Browse Folder, and now we're going to choose that annotated test set that we just created. And select that. It's going to load the images. And you can change the size of the gallery. Control scrolling works as well. We're going to load that data set that we just created, and that's so that we have the categories that exist over here, so we can control what we're annotating. We're not going to annotate the whole set because that takes forever. So this demo is going to cover how to use the auto annotation feature to help make this process much quicker. But initially we're going to have to annotate about 25 of each type. And I typically prefer to annotate those. See, these ones have multiple ones here. Just to make it easier to count, I'm going to skip those and go to easy to classify. So for now I'll do 25 QRs. Old school, super fun style. And it doesn't have to be perfect, just generally good. and I'll try and make this quick. So normally when you would have thousands of things to annotate, this would be very painful. Now, it looks like there are some duplicates in this data set, like these two appear to be the same. If you notice that and you hit the delete key or reject selected images, this just moves them to a rejected folder on the file system. So here, if I go back in here, you'll see in your tutorial data set, not that one, sorry, annotated, you'll see now a rejected folder. So there's a concept of rejecting the images right out of your data set. Here we go. Let's annotate these really quick. And it is important to make sure you get the proper ones, because bad data gives you bad training. I guess that goes without saying. Let's see where we're at. You can see how many you've done already. Basically you have to save. This, I'll have to fix this bug later, but save all changes. There I can see I've done, basically your changes aren't saved or calculated till you hit save. It's all in memory. This is what puts the text files on the hard drive, or in the space. So let's get this to 25, and boom. It looks like someone augmented this data set already with various spins, quality levels, zooms, and that kind of thing. Though I am going to leave augmentation on later just because it's such a small data set that we're working with here. Let's see, what's this at? 17. See, I've only done 17 of these, and this feels like an eternity. So this auto-annotation feature is not only a time saver, it'll save your mind for better things. Okay, these are bad examples. Insane data set. Okay. Almost there. There we go. Let's see, this looks good. Just a wide range of these things. Where are we at? 24. Maybe I'll have this counter fixed to count in real time like it should. So now I'm going to start tracking data matrices, which are down here somewhere. Here we go. So down in the data set, you'll find, in case you're wondering, a QR code has these 3 dots, where a data matrix you'll see has like kind of this solid line, like an L shape. There's no dots, and then there's these little quadrant counters, which I won't explain what they are at this point. But in fact, this isn't a very good image to do something on, because I don't want to do multiples right now, just to keep it simple. Otherwise, it's hard to count and make like a good set. But it'll be assumed that you're working on a data set that you know what the differences are between things. Let's see, in this case, here we go. I can see that there's 5 unsaved changes, so when I get to 25, at least I'll know that I've done about the right thing. Now there are other packages out there like RoboFlow that actually have similar type of features, but they aren't necessarily custom, but you can train models and work with it. The reason why I wrote something like this is situations where you work in an organization that really requires privacy over the domain of the thing that you're recognizing. So there could be aspects that are proprietary to your business, or just the data that you must train on is considered to be, oh, that's not a very good example. Let's get rid of that one. It's considered to be very sensitive, and therefore using products that require a SaaS solution and an NDA and all sorts of trust is too much. And so I thought this would be a nice way to just let people work with things right on their own PCs with no external service requirements. Where are we at? 16. God, I've done so many days and days of data annotation that once we solve this problem forever. But this will help, as you'll see in a moment. So fast forward the video until this is done. Whatever helps you think about annotating. Here we go. Another. So some terrible examples, some decent examples. Where else? Here's a good one. Sample. I'm at 24. 25. Okay, save. Though apparently I've only got 23 classes of data matrix, which doesn't really make sense. I must have missed something. Oh, okay, well that's fine. I will add a couple more. Let's see. There's one. There's a good, terrible looking one. Done. 25. Perfect. So now that we've got, here's this filter to annotated, we have a set of 50 annotated items, about equal for each group that you're classifying and trying to recognize. We're going to want to split, and this is a very small data set. Normally, where was I? Sorry. Normally, you're going to want to have hundreds, if not thousands, of good examples. But it just sucks doing this process. So the point of this will be to take this, make a very small data set. We're not going to have a test part of our train, and we're going to scoop this up to 80% for your main training set. We'll do this test thing at the very, very end. And we're using stratified splitting, which in this case won't matter, but later on it will. It looks at class combinations where you have multiple classes in the same image and make sure that the splitting is a bit more balanced for you. So let's do the split. Here we go. Oh, sorry. Click on the source data set. So in this case, we're splitting the annotated test set that we just worked on. We're going to output it to the working folder, which was back here, because that's what we're splitting into, that test train and val set typically. So when I execute this split, we now have a good working folder for the training to work against. So if we go back here, you're going to notice train and val, and each one's going to have pairs of JPEGs plus their annotated data from the session you just did. So now we can start the auto annotation. Or actually, the very first time we auto annotate, we do need a basic model. So the very first thing we do actually is training, and we're going to load the data set, which when we created, actually I'm going to cancel this. When we created this data set YAML file, it put your classes in here, and it also put your working path. And that's the path that we have the data set split going against. So that being said, we'll load that data set now. Here. Okay. We're going to leave it on 8 nano for now, just to make it go quick. And the very first time we do it, I'd say go for, say, 50. I have 16 gigs of GPU, so you may need lower amounts if it starts going over your GPU memory. In this case, I want data augmentation. I won't explain all the settings, but this just helps change things slightly, so your recognition's a bit better. So start training is what we'll do next. If your device if you're not getting your GPU here, by the way, and it says CPU, and you have a GPU, it just means you need to uninstall the CPU version of PyTorch. It's in the README file, and then you go to PyTorch and get the latest drivers for your CUDA version. And if it is working, you'll notice this training is going to be very quick. I've included some useful graphs. This you typically want to get down below 0.5. The first couple times you do it, it won't, because we're preparing for auto training. But I also put some graph information here. What looks good, what's bad, and a few other interesting graphs for those data science-y types who love these things. Anyways, I'm not going to explain all of this. I do like to look at, sometimes just what got selected or seen, but also the confusion matrix, which I can see here. The QR and the data matrix are not getting great hits. Like this diagonal is not looking great yet, but that's okay. We have a very basic set. We will now start with auto annotation. In order to do so, we need a model to load. So what we do is we go to model management and we find the models in this project. And this will bring the latest trained one to the top. So we'll double click on this and go back to auto annotation. The folder we're going to select is the annotated test set, that folder where we put just the images in and that we're also annotating into. So we'll select this. We're going to load that data set again for this mode, and that tells it how to do the split. So what's going to happen here, let me just start, let me go down a little bit first. So you'll notice a bunch of settings. Leave most of them alone for now until you understand what's happening overall. But the split's going to remain about 80%, 20%. But you can modify all these. This is where you can change your batch count if your GPU isn't very big, or you think you need different settings for your particular scenario. I do have the workflow mode turned on, so now all we have to do is hit start. It's going to run inference and then ask for your input. Just basically it wants you to select the ones that you think are good. It takes, about 30 seconds typically to do a batch like this. And kind of the goal here is the first couple runs will be not as accurate, but it just gets your data set a little bit bigger to start, and that brings up the accuracy between each of the runs. Here we go. So now we're ready to review. I'm going to go right to the approved. The approved is just the ones that are higher than 85% confidence. So I can see that looks good. So I know that QR is red and data matrix is green. And I can tell this is wrong because this QR code's got 3 boxes. In this case, instead of rejecting it, I'm going to keep it. Just call it a QR. And when I change, it updates. Also, this is identified incorrectly as well. In fact, it identified a lot of QRs wrong in the approved. So I'm not liking that a lot. I'm probably going to select like this one's wrong. So I'm going to hit the R. Like you can not these are filters, but there's also the ability to reject or approve. But I just use the keys A or R. So we're going to reject this by hitting R, and what it does is it puts it into the rejected folder, which are the images that are way too low to bother to look at. And then no detections are things where we just, didn't get much. So there's a couple that are correct. This one looks correct. That is a data matrix. That isn't. And I could do this whole click drop down thing, but I'm just hoping to see if I can automate this a bit. So I'm going to reject this and this. And also you can hit control and just draw and you can select. So I'll reject. Data matrix is correct. These are incorrect. Oh, no, don't hit delete. Just hit R. I'll explain it later. Delete goes to the /rejected folder on your hard drive. R rejects them as just a filter, and it's only temporary for this particular annotation session. So it did get a lot of QRs wrong, so we have to probably balance. Oh, there's one QR code that's correct. The reason I'm rejecting these is I want to put everything that's going to be approved in here. So it did pretty good for those. For the data matrix recognition, let's go on the review tab, which is a bit lower, and see if I'm just going to approve. I'm not looking for incorrect, so I can see this one's correct. It's a QR code, so A approves that one. I just want to find a few more QR codes, and that's just to help out the next run. So you can just go here and select. You know what? I don't think that feature's working as well as I wanted, so don't worry about that for now. Let's see here. QR code, approve. This one's pretty close. I can just delete that and put it back up. Approve. So a lot of these QR codes actually are fine. It's just finding a few that are valid. Like that's a data matrix. So, the first round does suck a little bit. Approve. You're just looking to approve a few of these. And if you accidentally approve the wrong one, it's easy to go fix. In fact, I see quite a good set of QR. So our next run's going to look a lot better, which I'll do in a moment. Pretty soon, there'll just be large groups you can select and just approve, which will speed things up greatly. They're like basically those are incorrect. I'll show you, like, if you had a group of ones that you liked, like these two are good and that's good, so then I could approve those, right? That's good. I believe these are QR codes, yeah. I think I've looked at too many QR codes for too long. Okay, so I think I've approved a good group. So if I go in here now, I can see these are all the things I believe are good. There's not a lot, it's enough for now. So I'll hit select all, because what I want to do is get to the next stage of retraining and annotating again. And I like the settings that are here already, so all I have to do is export these selected annotations, and that triggers the next step in the process. So as you'll see, we go right into training. And this one will probably take a little bit longer, and that's now because we have quite a few more images than we did originally. So it means that there's more steps that have to be calculated when it's doing it. So you can go down a bit and see the text log. I've never liked looking at it as much, so I output this. Of course, there's all the other types of metrics that might be interesting to you. When the training's finished and it's ready to annotate, it will auto load the new model and then run inference against your data set again, and then you can resort them by confidence filters, and hopefully in the first couple runs get higher and higher accuracy, and that way get larger sets of correct annotations grouped together. So what we're hoping for is to see this start to drop down towards 0.5, for example. At least I find that's when it starts to look better. Oh yeah, what I was saying about the steps here, how those are typically calculated as far as total steps will be your number of epoches times the number of images divided by the batch. So if you have 10 images and you have 50 epoches, that's 500 steps, because 10 times 50, right? Because every epoch is one full run of all the images. But then when you do a batch of 16, it divides it by 16 because it's doing a grid of 16 at once. So it generalizes better, but then it decreases the steps as well. So that's something to think about sometimes. If your batch is pretty big, maybe to put your epoches higher. Right now it's running the inference. It'll actually pop up and tell you once it's ready. I should scroll up. If you scroll up, actually there's a progress showing you that it's ready for your iterations done and the model's been updated and inferred, and you can review and select. So what I would prefer to do is see if I can't get really high approval things and just see what I see in approved here. So that's looking better already, except for this one here. Now it's starting to do grouped ones. I'll just fix that little guy. That looks good, but maybe a couple of these together will help. These all look pretty happy. If you want to see a bigger view, actually one thing you can do is expand the gallery and just Control Shift, or you can slide the slider and make it a bit bigger, so it's a bit easier for you to see your classifications. And then just go down page by page, make sure everything looks sane. Actually, there's quite a few more. How much is in this category here? There was a number, it's missing at the moment, but there's quite a few. Let's see. Yeah, that looks good. See, this is when it starts to get easier, and that's just round 2. So if you have thousands of annotations to do, and this starts to work relatively well, because it's sometimes you're just looking at the difference is it finds the bounding box, but it's just not feeling confident. And those can be like selected and used quite well, which I'll show you in a moment. I'm just going to make sure these look good. Like this is no good. Let me see. So to fix this one and get the screen back, you could retract the gallery, or you could double click it, which will do a retraction for you, and then just select the QR code. There you go. And then I'll expand it again. These all look good. Where's my thing? I'm practically a barcode detection unit at this point. This one here I'm too lazy to correct, so I'm just going to hit R and reject it right from the set for now. Maybe in a future round it'll get detected easier. Same with this, it just selected it wrong. Just reject it. That's not a QR code, so reject. I don't feel like dealing with that. So just rejecting this here too. This is an Aztec code, so nope. Don't feel like hitting that one. So it is important to reject or get out of this approved set the things that you're not going to approve, or it'll take way longer to generalize the right pattern for you. Let's see, what else? This almost looks like it has two boxes, and you do have to double check that, actually. It does. Sometimes it gets two detections, funny enough. And so in this case, this is a data matrix, so just hit delete and then go back into expand. Okay, where was that one? It was yellow. It was somewhere. Okay, here we are. Almost done with this one. Yeah, the only hard part I have been able to figure out removing is having to look at these after to make sure your data set's good. That's upcoming. So for now, I mean, this is a good set. This is 156 already, making the data set bigger. But if I go to review, I can see things that had a much lower class. Here, like this would be the thing. Let's pretend it's just that one issue. Delete. Boom. Usually click off to save, hit approve. I mean, that one looks obviously like it did a good job. So there's a lot of these you could, but then this here I can't approve. I can see there's two selections on it, and up here you can see two annotations. But this one's approvable, you know. So there's a lot of things like this that you could do. I don't feel like doing too many manual approvals that are not correct together. Or you could just, one way to do it is, again, expanding the gallery and just looking for things. But I think what we have under approved is good. So let's select all again, export, and it will start training. Now go have a coffee and do some coding. Come back in 5 minutes. But I found this process, if I'm trying to annotate thousands of items, shortens that time down quite a bit. And you can also experiment, because again, you're not doing the perfect training at this moment. It's just enough to get those bounding boxes kind of there, and they don't have to be accurate at this point. So what you could also tweak is, changing the learning rate. So making the learning rate even faster, because you're running a low amount of approaches anyways. You can or keep the learning rate where it is, increase the approaches, and add more variability in the augmentation options up here. So the degrees things get rotated, or a perspective, or flipping left to right. Like right here is a 50% chance that it gets flipped horizontally or vertically. Mosaic I'm not using at this point, but all of these are you can see what they do. This is looking okay for what's happening so far. I'll see if I can't try and double time this video. Okay, we can see that the training round has completed, and it's just quickly running an inference on your data set. And we're on iteration 2, actually on iteration 3. Okay, so hit OK. It's been sorted, and we're under the review. Okay, I'm going to go right to the approved. I can see there's 157 in here, which is great. And how good do they look? Let's see. It's actually looking pretty good, because I didn't give a lot of training on these before. You have to remember those we skipped. So that's great. There, I do notice it's not quite getting in there the way I was hoping, so I'm going to go back to my... I'm just going to remove it from the set from now. Let's see. So we'll do a quick zoom through, but it's starting to look like it's doing well. I'm going to remove that one. Let's see what else here. Get rid of that one, because I can see there's 2 that it didn't detect yet. This is all looking great, though. And we're only like in only 2 inferences in here, or 2 trainings, fine tunings. Yeah, that's good. Yeah, that looks good. Good. That one doesn't look good, but I'll just hit reject. No point playing with that. It'll just happen next time. All super awesome. It's always nice to see something you've written work. Some of these images look the same. They're just like slightly tilted or slightly skewed. They're augmented in different ways. Though in this case, the guy who created the data set did some augmentation himself, like taking a can and tilting it, but hey, it works. So good on him, because he created our tutorial data set today. Let's see, it looks like we're almost good to go here. I think we... Oh, the rest are amazing. I don't even have... I'll get rid of this one. I'm not even going to go through the other rest of the data set. I'm just going to approve all these in a second, let it do a round, have a coffee, and perfect. Yeah, so we're going to hit select all and start the process of export annotations, and boom, and go have a coffee. Okay, and so that round of annotations and inference and training is completed. And we had, let's see, we have 500 left. So it keeps counting down from the original amount. So in our case, I think we had almost 900. So 400 have been annotated so far. The ones with no detections, before it was a huge amount that couldn't be detected, and now it's a relatively small amount. And if we go to approved, which again I set very high, probably even a lower threshold now might be appropriate. I think I might lower that down to like maybe 0.85. It's probably getting good. So hit apply thresholds. Whenever you apply thresholds, it will, let me just see if that generally looks. Yeah, it generally looks good. Okay. Whenever you apply thresholds, it applies to all of the categories and redoes them. So be careful if you've been organizing things, because it will redo them all. I'm still going to reject this because it doesn't have all the buttons in there filled. So hit R. And let's see if I can't see these quickly. This actually looks good because I didn't show it what partial data matrices look like. So I'm feeling very... There's actually 300 of these in here, so that's almost too many, but we'll see. Where's my scroll? I'll try and do this very quickly or speed it up in the video. Like I can see there's a problem here. So what I'm looking for right now are things like this. Maybe I'll actually just get in here and delete that because it's easy enough to click and do that. Go back to my gallery. I can see the yellow highlight. Let's see. Do I want to select that one? No, I'm okay with that. So far, so good. So I'm looking for things that just don't make sense, like double annotations and spot checking what looks wrong. If it's really hard to see, like in this case, I'm just used to it, so I can see here there's an extra. In fact, there's one. I'm just going to manually fix it. Like this Aztec code isn't something we're doing, and this also has a QR code on top of it. You got double selected, so having that distinction there actually will be worth doing. So some of them it doesn't hurt to get in if it looks like it's a complex one. You'll get a feel for it. That was this. When I click off, I can now see the update. Let's go down again. So auto annotation doesn't mean you don't have to annotate. It just means that you'll do less annotating, hopefully. So far, I found it working pretty good. In fact, even now it's showing quite promising results. Now, it's not good enough that you can just select everything every time and say yes. In the later stages, it does get pretty good. This here I might fix just because it's so close, and it's, just make sure you get the right, there we go. Back to expand. Those look good. I actually know those are QR codes because I've seen this data set already. Let's see what else. It's all looking, except for this one again, another one. I'm going to reject that. I don't feel like editing. Those look good. Good, good, good. That's missing that one there. I kind of want to see if it gets it later. This is very good, actually, because it did skip that, which is usually gets caught on. Yep, I actually got both of those. It's looking very good. So as you can see very quickly, it's reducing the amount of annotations I have to be detailed about, but just quick validation check at a high level. I can even see it's getting multiple spots and everything. Yeah. Let's see what else. It's cool that it figured that out, I think. So you can tell pretty quickly it's able to generalize. And we didn't even do a great training yet. This almost looks like it's got too many. I'm going to go in here. Yeah, I don't know why I just looked off. I can see that there's too many. I don't like it. I'll keep the image. I believe that's a larger one. So let's just do that. There we go. I could have just rejected it for the next round. It would probably pick it up. But usually within 4 or 5 rounds of something like this, and you basically have your whole data set done except for a few stragglers, which is pretty quick. There we go. Actually, that all looks amazing. I'll look at the review. Look, there's not even that many left here. That's pretty good. So I can see that looks good. Like I might hand approve a couple. That looks like I can see this still sucks. That looks good. Nope. Yep. That one's missing a corner piece, so not good enough. There's 2. I can see 2 colors. That's also no good. So a lot of these aren't good, but there's still a few that kind of are. That's what I'm looking for. Like that looks good. But I think we're generally no, we're good. So I'm going to go to the approved, select all again. And you can even lower these approaches to wherever my training settings are, to like 25, because as you get more and more images, this becomes more impactful. In this case, because I'm going to speed up the video, I'm going to select everything, leave it all the same, and export. And I'll just fast forward all of these terribly slow, boring areas, and I'll see you once it's finished. Out of 900 images, we can see now that we have about 177 left. I'm going to go to the approved thresholds. And here, like, I can see we're getting so close. I might delete some of these manually. There's actually detected. Well, that's actually part of the image. I see. That was my bad. Let me put this back on. Data matrix. You can just draw them as you need to. Like in this case, I might just finally draw in the QR codes that it's not seeing. Though I do see below that it caught them here. So that looks good. How many are in here? 79. Okay. I'm going to keep one of these. I'm going to delete the QR code that is not a QR code and manually add a couple. Okay. This is looking better because it's skipping the Aztec codes, though it does get confused on these point dot code things. That's okay. We'll do a couple more that fix that so that that's done. Remove that from the data set altogether. That's funny, you can barely see these, but these are QR codes. Very hard to see. It's probably not the best data, but we're just using the original data set. This is not a QR code. Just get rid of it. I guess it looks kind of like a QR code. There's a good example of where the generalization's starting to work, because this was pretty badly damaged. So that's quite good. That's a very promising sign. These, I don't really know. This is like a dot code or something. And this looks kind of like a data matrix. I'm going to assume that it kind of is. Though I don't even know here. It looks like it though. It's got the dots. Okay, what about these? So I can see data maxi code, so that's obviously wrong. Aztec code's wrong. Actually, I'm going to reject this whole one. It doesn't look good. There we go. More of these do look good though. And so on and so forth. Should remove that one. And yeah, there we see this all looks pretty good, so that's nice. That's 76, and then there's about 55 of these, which are not quite as good as you can still see, but it's coming. Like there might be just an easy win by deleting that. Oops. You have to switch off the image in order to save it currently. That looks good. That one's fine. That one looks like it has two of them. Yeah, if I take that off, that actually could be approved. So sometimes you might find a finicky few like this. There we go. Now it looks. You have to click off again, yeah, to save it at this moment until I fix that. That looks good. That does not. I don't really think I like that either. that's good. You get the idea. So what would happen is at this point we would expect the annotations, we'd go through another round of training. In fact, maybe we will, I'm just thinking here. Yes, we will do another round just to get a higher level for the next part, and I'll just fast forward this. So a couple more approvals. This is actually a good one because it is actually both. Is that a QR? See, that looks more like a data matrix. It's hard to say. All three are actually. I'm not going to bother with that one then. That's a data matrix as well. I think just selecting a few of the small ones might help. Okay, I'm going to look for that same one. I just approved this one by accident. And you do technically want all of your data to be as good as it can be. So let's see if I can find that image. There it is. That's the same image. That one is a data matrix. There. So I'm going to go with this set. Select all. We'll do one more export. Okay, and we're back. So here with the data set split, we're going to do this again, assuming that our data set's completed. In fact, let's go take a look at our finished data set. So after all of the auto running, everything's placed in the same folder that you brought, that annotated test set. So now you've got all of your pairs of text files alongside the images. The thing is, we're going to want to get these into the working folder, but with a better split than was there before. So I'm going to delete what's in the working folder already. These are from the auto validation or auto training. It doesn't even have a test set in there yet. Okay, and let's actually do a real training. So I'm going to run this again. Okay, so let's actually split that data set and have a better set of ratios. So in this case, we're going to do 70% training, 20% for validation still, and 10% is for testing. And that way we can look at an unseen data set once we're done and verify what we've done. Now, just as a forewarning, I haven't finished the full auto annotation just for brevity. So we're just selecting a decently trained set. So we're going to choose the source folders being that annotated test set that has all of the images. And there are 86 images that we haven't annotated yet, but close enough. And the output directory is going to be the working folder again. And we are going to execute the split. And this just copies them, so you don't have to worry. It's a non-destructive split. So now when we go back, we can see in the working folder, test, train, and val, and that will have your various aspects, like 164 in test, 1100 in training, and validation should have about 300. So that's good. So we actually annotated a lot of this data set pretty quickly. So now what we want to do is actually do a real training. So the real training might be something a bit more involved. So maybe we want to use the 8S, for example, the small. The nano is very quick for inference. The small is quite a bit more accurate. And then, of course, the models go up based on how much memory you have. I might actually lower my batch size. Actually, I'm fine, I believe, with my batches. And the approaches could easily be up to 1,000. I like to do about maybe 2,000 steps, 1,500 to 2,000 in total. So again, the step count would be your training data, In this case, it's 1164, but that's also with annotation file. So we have 582 images. Okay. And we want to do 100 epoches, so 582 times 100, and that's 58,200 steps. But since each step it does 16 evaluations at the same time, we end up with about 3,000 steps. That seems a bit too much. I want about 1,500-ish, so I'm going to stick with about 50 here, and that will make me happy. And I think we're going to start training. And do I want data augmentation? I think so. I'm just going to make sure my augmentation is good. In this case, I don't want mosaic, which combines 4 images into one, and that doesn't help with detecting QR or data matrix codes, but in some other things it might. I'm not going to bother with these. I'm going to leave it the defaults for now. The export to Onyx can be used if you want to use these models in Microsoft's ML tools. So I think we are good to go. So I'm going to hit start training. It's going to download the base model for me. So we're using the Yolo V8S. Well, this list, of course, doesn't show, I don't think it shows 11. Oh, I did bring 11 in perfectly. Yeah, so it supports 5, 8, and 11. And the reason I went with 8 is it works very well on details, such as what we're working with for the barcodes. And I don't really do a memory GPU RAM display in this app at this point, but I can see pretty quickly it is using my GPU. I'm only using 6.2 gigs of RAM. And so I know that I've got 16. So if I end up going over 16 here, and it goes into the shared, you're going to see the speed going huge down. So in this case, I have 13 minutes remaining, right? But if I ended up going onto the CPU, the time remaining would end up being about, 2 or 3 hours, maybe 5 hours. So it's a huge difference, sometimes even days. So I'm going to go double time this training, and we'll see you guys in 12 minutes. Okay, so now that our main training is complete, we'll get some graphs. These typical things are found actually in the results folder. So if you go look at your training tools under the runs, under train, you'll see the various auto annotation trainings as well. We'll order by date, the most recent training that you did. The weights are stored in here. Last is just the last one. Best is the most recent one. They tend to be the same. It depends how big your training is. The arguments that were used to train with, as well as this was the script that was used to also do the training, because I do create a training script in order to do this. So that's where you're going to see this info coming in from. I'm not going to cover over what all the metrics are and what's good at this moment. That's for investigation. But I'm looking at the confusion matrix. So this is, in fact, I'd still like it a little bit better, but this is actually pretty good. Usually you want a diagonal of things. So the background is on its own. Here's a couple of things that detected as background that really were a data matrix, or that it was detected as a data matrix, but it really should have been background. So this is a very nice diagonal, and QR codes are almost perfect, I think, actually, which is very nice. So what that would mean is, here, let's go load this model. Okay, so back to find models and project. Let's load the most recent one. Back to folder browser, and in this case, we are going to go back to that test folder now. So there's no annotations, it's unaware of them. And we are going to run inference on the 82 images. And this will load that model up and very quickly let us know how it performs. So there's an example of the background part. But we would probably, typically when you're running, let's say we were doing a test inference, we would prefer to have something maybe, let's say 0.75 or higher, right? And this will update live. So typically if you're just trying to see how this model would infer against the images, you can quickly see that this is actually looking pretty good. Yep, I can see all these are properly done. So that's very good. Even here, that's yeah, quite well. And so yeah, we can see now that our model's trained up and is detecting fairly accurately your new classifications. And when it does the detections, it actually detects and gives you out the bounding box, which is how I'm able to draw it. So there it is. And that's the tutorial for this auto training and annotation.